Well, as usual, we have saved the best for last. If Martin Casado is the Plato of networking, then Guido Appenzeller is the Socrates. He will ask you questions you didn't know the answer to until he asked you, and then in conversation that will come out. Guido has a fantastic history. You can read some about it, of course, in the program online. But as an inveterate entrepreneur and a founder of Voltage Security and now, of course, Big Switch Networks, he really tries to get this stuff to market. He got his PhD at Stanford shortly after, around the time of Martin. He actually made 1.0, the version 1.0 of OpenFlow, a real thing, got it out there, and he's taking things to market all the time. Now, Guido is from Germany, but he has consented to give his talk today in English, not in Japanese, which he also speaks. Please welcome Guido Appenzeller.
Great intro. Super. Can everybody hear me? So first, I want to say I'm really excited about being here today. Reflecting back on the last year, it's really amazing to me how much momentum software-defined networking has and how far the industry has come. And so while I was preparing this talk, actually somebody asked me when we were back at Stanford developing the OpenFlow standard, did we anticipate how quickly all of this would happen, how quickly OpenFlow would go from research prototype to something you hold a conference about? And the answer is, I at least absolutely did not, and I think nobody at Stanford at that point anticipated that. Not sure how many people of you know that, but this whole idea is actually not a very old idea, right? We started, the earliest document I could find about an OpenFlow release is actually for the 0.2 standard, which was in late 2007. I joined in 2008, and then the standards development took its course. And in parallel, we started seeing networking vendors implement OpenFlow into switches, specifically hardware switches. And while 2009, 2010, we were mostly doing prototypes, it was really only in the last 12 months that first NEC announced general availability for their switch, followed by IBM and then HP. And we're at Big Switch, we're working with a number of hardware vendors. And it's safe to say I'm very, very excited about what else is going to happen later this year. You can see some of that at the demos here at the outside already. Despite all of this momentum for OpenFlow, I at the same time think, and SDN in general, I at the same time think that we're at the moment at a little bit of a crossroad. And the big question is, going forward, how will SDN evolve? How will software-defined networking evolve? Will it go a direction where it's very open, around open standards, or where it's closed into vertical solutions? And I'm actually convinced that if there's a single thing right now that can kill SDN, it's moving it to a closed model. And so for the rest of the talk, I actually want to convince you that open versus closed for SDN is something that's really, really important. So if you look up in Wikipedia, the definition of software-defined networking, you can find this one here. I think actually Martin wrote that. Now, if you actually start a company like we did and go out to a network administrator and try to sell that, the network administrator hears a very, very different story. So to him, software-defined networking means there's yet another vendor in my mission-critical network. If the controller for this new piece of software, if it ever goes down, my entire network goes down. It carries the integration risk for making sure the controller works with the switches is all carried by the network administrator. And this is brand new technology, possibly made by a startup. So this is actually not very attractive. There's a lot of resistance you're facing. If you're looking at sort of the other features from a network administrator's point of view of SDN, SDN allows you to write your own control plane. Now, who would actually do that? If you're running an enterprise network or a data center, would you actually want to write the software that runs your network? It's actually very hard to do that. It requires a large team. You need people with different skills, distributed systems, networking. It's pretty hard to do. And I originally had written here that nobody does that. That's probably an oversimplification, so let me change that slightly. In the hyperscale data center, it does make sense for organizations to write their own control planes. But for most organizations out there, we don't think it's very likely that that's going to happen. Now, if you don't write your own control plane, you just buy a control plane from somebody. What have you really gained? Now, if this is a completely closed control plane, right, the answer is not really much. It may actually help the vendor to write better software. For example, if you look today, the vast majority of network virtualization systems that I've seen that have been developed recently, pretty much all of them use some type of centralized control plane. It looks a little bit different in each application. But so for some things, I think using SDN is just fundamentally a much better way of developing this type of software. But you as an end customer, you don't care about that. As long as the system works and does what you want to do, whether it's software-defined or non-software-defined, it doesn't really matter, right? So why are people adopting SDN? And I can tell you firsthand that we're seeing adoption as a broad trend across the industry. The key reason for me that changes the value proposition about SDN is SDN being open. It's not about writing your own control plane here. I think few people will do that at the end of the day. It's mostly about integration. You can take an open source control plane and modify it. You can buy a control plane that has APIs on top and then build your own lightweight applications on top of it. In some cases, these applications, they actually look more like scripts rather than full-blown applications. At the end of the day, I think what most people will do is they will mix and match open source components with commercial components. And I want to give you 3 examples for the rest of the talk that basically show you how, in different cases, open manifests itself and how this really is that provides the value for software-defined networking. They're private cloud, VArmor, and the integration between top-of-rack switches and virtual switches. So if you're building a private cloud into a company, and part of it is great. I mean, the first thing is suddenly your internal application teams, they can go to a portal. They can reserve a couple of virtual machines with just a couple of clicks. But then the next thing that you notice is the number of trouble tickets or change requests that you're seeing in your network is going up. Now that it's suddenly much, much easier to create new applications, new groups of applications, the effort to configure your network in the right way goes up with them. And SDN has been touted as a solution to address that. And I think it's true, right? If you simply build an SDN solution that's just standalone and separate, and sits is independent from your cloud management solution, you haven't really gained anything, right? You're now using a different application to manage your network. Maybe it's a little bit more efficient, but that's really not the advantage here. The real advantage comes in if you take your network, your software-defined networking solution, and via an API connect it to your cloud management solution. So, for example, OpenStack has a plugin called mechanism called Quantum, for networking plugins, and then you can use that to drive your network. So for example, if somebody signs up for a dozen new virtual machines, they get a virtual network that goes with those virtual machines, and they can even potentially specify what service type they want. Do they want layer 3 connectivity? Do they want layer 2 connectivity? Should broadcast be allowed? And so on. Now, for this to work, your software-defined networking platform needs an open API, an API that these external services can talk to. Ideally, it would be a standardized API. I think we're not there yet, but as long as it's open and people can access it, it gets you most of the value. Some of the primitives you need there is creating a new network. Whenever you create a new tenant, for example, you create a new network. But also there's some calls that go the other way around, where the platform suddenly figures out there's a new host here. I've never seen this before. That probably means some of my state isn't quite correct, and queries the cloud management system to ask, what machine is that has been moved here? Have you migrated something, or to update its data? So that's the first principle: open APIs. Second example I want to give is essentially around service insertion. So firewalls traditionally in data centers have been used to filter traffic that comes from the outside and wants to go inside the firewall. But we're seeing more and more use cases where companies are trying to deploy firewalls for east-west traffic in your data center, meaning there's two virtual machines, both in your data center, are trying to talk to each other, and you want to run that traffic through a firewall. Doing that is actually pretty hard, because if you think about how the traffic flows, right, by default, traffic goes up to the top of rack switch and then back down, right, through the hypervisor switch. And you have your firewall potentially running somewhere in a different rack. So there's several problems here. I mean, the first one is, how do I get the traffic to the firewall? The second one is, assuming the firewall wants to make a decision about quarantining the traffic between virtual machines, it now has to tell the network to stop forwarding traffic between these machines or forward it to a different place. So VArmor is a startup that's trying to solve that problem. And what they did is they took Floodlight, which is basically the open source core of the controller that we're developing at Big Switch Networks, And it's under an Apache license, so you can just download it and build on it whatever you want to. And then they built their own application, the VArmor application, and put it on top, which talks to basically their firewalls. And what this allowed them to do on the engineering side is to get up and running very, very quickly. They had full access to the integration layer. So basically, if how a packet flows through a software-defined networking platform, if they didn't like that, they could go in there and change it. They could take the core modules, such as packet forwarding, and host management, and modify them as needed. But more importantly, it also worked with their business model. If you're a customer and you want to deploy, for example, VArmor software and our software, you can easily do that. You can mix and match different applications on top of that open source platform. It also means that if ever one of these customers actually wants to move from the open source controller to a commercial controller, they can do that because we're keeping API compatibility. And last but not least, there's no lock-in here for VArmor. It's Apache license, so if we ever part ways, they can do whatever they want to. They have no dependency on us. So that's the second principle, open source. And for the third example, I want to talk about integration between virtual switches and physical switches. So one use case we've seen with our customers quite frequently is that most of the data center is virtualized, but not all of it. I mean, if you're running a large enough enterprise data center, typically there's always some things that you still have in hardware, layer 4 to 7 middle boxes and things like that. So in order to get traffic from a virtual machine to a physical server, you can't rely on your hypervisor switches. So basically, if you're running a fully tunneled mesh, tunneling is often a good idea in these data centers because of the state issues that were mentioned in earlier talks. So if you're running a fully tunneled mesh, then what do? One thing you can do is you can encapsulate the traffic on the vSwitch, stick it in a tunnel there, and then the other side, the top of rack switch, decapsulate it. For that to work, your top of rack switch needs to have tunneling capabilities, which specifically the high-density 10 gig switches often don't have. There's other solutions such as tagging the traffic or just switching it directly and watching out for duplicates. But what all of them have in common is that basically the different points that the traffic passes through have to be very tightly orchestrated. So I have to, for example, set up a tunnel on the top of rack switch and the vSwitch, and then make sure that the packets get pushed into that tunnel and taken out of the tunnel and forwarded to the physical end host at the right time. In order to make this possible, I need this tight coordination between virtual switches and physical switches. We need open protocols. Usually when we come to a customer, they already have made their choice for best-of-breed switches, and they have made a choice around what hypervisor they want to use. In order to provide this fine coordination, we basically need one type of protocol that the control plane can talk to both of them. Right? If we have completely separate protocols, meaning and closed protocols, meaning controller of one company can only talk to a switch of one company, and controller of the other company can only talk to the switch of the other company, this level of integration just isn't possible. So that's my third sort of pillar here, open protocols. Putting it all together, we think that in order for SDN to be successful, it needs to be open. We need three things: open APIs, meaning you must be able to talk to the software-defined networking platform; open source, because in some situations, doing the integration, the orchestration is just too hard to do; and open protocols to the switches, whether physical or virtual, at the bottom. If you actually want to see some of this live, there's a couple of demos here at the Open Networking Summit where our partners that we're working with are showing some of the technology described in here. If you want to see cloud integration, you just saw already in Gang's talk. Have a look at the Dell booth, what we're doing there. For open source, have a look at VArmor. They also have a demo here to see the firewall example. And then at both Extreme and Arista, you can see the open protocols, how we're using OpenFlow in order to talk to these switches. That's all I had. Thank you.